Good afternoon, Cloud Natives, Rick. It's great to see so many of you here, so many of you interested in digital sovereignty. I'm actually quite surprised that we have our own track. And it seems to be quite a hot topic at the moment, digital sovereignty, right? But there's a question that seems unanswered is how do you actually achieve digital sovereignty? And today I'm here to tell you how it's done. And I'm also joined by Andreas. He has no idea about digital sovereignty, like he has no clue how it's done. But I think he also wants to say a couple words.
Yes, good afternoon, everyone. Thanks for the kind introduction, Jakob.
Yeah, well,
because I'm here on this stage today to make my case that the public cloud is perfectly good for all of your use cases, even though Jakob disagrees. So rest assured, you can use your favorite hyperscaler and leverage their scale, use their innovative services, and still remain in the driver's seat.
The driver's seat. There you go. The sales pitch starts. What I offer you is actual full control, right? So you have ownership of your system, you have transparency, you have self-reliance. And how do you do this? It's very simple. You just operate your entire stack on open source and on hardware that you own. But before we start this argument again, maybe we should give some context. So you're a partner at IPT, right? And you help companies in the insurance and banking sector go onto the public cloud with their public cloud journey, right?
That's true.
Okay.
And to introduce you to the audience as well, Jakob Beckmann, he's a fellow consultant at IPT as well, and he mostly works in the public sector and somehow still prefers the private cloud.
Yes.
And he helps the Swiss government to design and engineer their private cloud services.
All right, but before we start fighting, let's set some ground rules this time in the hopes that this works. No interrupting one another, no shouting, no physical violence, and last but definitely not least, no like marketing sales pitches as the ground truth. Deal?
Fine, deal.
All right.
So let's start by defining what we're actually arguing about. And let me be neutral here, at least for once, for the beginning. So, digital sovereignty. Probably you heard a lot of definitions already, so let me give you mine. So, digital sovereignty isn't just black and white. Simply put, in my definition, it means an organization has carefully and consciously thought about the risks they want to accept regarding their data, their infrastructure, their software, and their operations. And hopefully they also get there so that they manage those risks. It's basically about agency, about freedom of action. And of course, sometimes it's about being independent and not relying too much on external actors. But ultimately, it's a choice. And every company has to find their own path. One that is practical, technically feasible, and last but not least, but also important, economically viable, because some people work in the private sector, right, Jakob? So let's start with defining three key pillars about sovereignty. So data sovereignty, technological sovereignty, and operational sovereignty. And I would say let's kick it off with the data sovereignty. I mean, we're here in Switzerland, and the common myth is that your data is only secure and sovereign if it's somewhere in a bunker under the Swiss Alps. But that's a bit outdated, right, Jakob? So
No.
today, hyperscalers, they have Swiss regions with dedicated data centers in Zurich or in Geneva, like Microsoft. And they guarantee that your data remains on Swiss soil. This is fully compliant with the revised Swiss Federal Act on Data Protection, the DSG, and with FINMA guidelines. So if you have your data on such a sovereign landing zone, you're compliant, they are isolated, and you're highly resilient.
Swiss regions. Yet another person that doesn't understand the difference between residency and sovereignty. Yeah, sure, your data is stored somewhere in Switzerland. That's great. But who owns the data centers that actually store that data, right? It's still the hyperscalers. Do you really trust them not to access your data? And even if you do trust them, actually, it doesn't really matter. Because under the US Cloud Act, right, any US court can just warrant that they need access to your data, and the hyperscalers need to grant them. So it doesn't matter if you trust them. What I offer you is full control. you own the hardware on which you store your data. And even if you don't choose to own it, at least make sure that it's owned by a company that isn't subject to some foreign jurisdiction.
Yes, physical control, Jakob, but not everybody enjoys spending their weekends in the basement trying to keep their servers from crashing, right?
Too bad for them.
So let's talk about actual data control. Have you heard about confidential computing? I mean, I talk about hardware level isolation. So that way, the root admins of the cloud operator, they cannot even inspect the memory of your running application. But to be fair, most of the cases you don't even need that. So consider customer managed keys. You encrypt your data in the cloud with keys that you bring or even hold. And if you want maximum security, you can manage those keys in a hardware security module. So what happens if you do that is that you host your data in the cloud, but to the cloud operator without the keys, it's just unreadable garbage.
I mean, come on, this is ridiculous. You don't trust your hyperscalers to not access your data, but you trust them to implement those cryptographic things correctly? What? But even if they do implement this correctly and you trust them, whatever, remember Spectre and Meltdown and probably even the copy-fail stuff, you're on shared infrastructure, right? So you run the risk that other tenants might still be able to access data by exploiting such vulnerability. Think about what EID does, or SWIU, I think how it's called nowadays. They run a decentralized trust platform where they ensure that cryptographic credentials are owned on the smartphone of every citizen and they share the information peer-to-peer. There's no centralized database that can be subpoenaed by someone. There's no middleman. There's no shared responsibility. There's just full cryptographic ownership.
Okay, you have a point here. So agreed, I let you have your keys.
Yes.
But what happens when you need to migrate or to move? You love talking about data portability, right?
I do love talking about data portability. Have you ever heard about egress costs? It's shocking me so much of that topic, I can't even talk anymore. Have you ever tried to get offline backups for the databases that you run in the cloud? Right? You can leave anytime Azure or GCP or whatever, but you want to take that data with you? Well, you have to pay for it. It's just a financial barrier. If I build on open standards, right, I can just move my information or my data to another provider as long as those two standards are compatible. I don't have to pay a ransom for my own data.
Okay, so let's take a step back.
All
Then you make a point here. It's a valid point about this legal overreach of foreign jurisdictions like the US Cloud Act. And when it comes to really highly regulated areas or even classified government data, then yeah, I agree. That's a risk that might become or becomes a showstopper. So let's say physical custody and keys on sovereign domestic soil, but also operated then by Swiss domiciled entities, yeah, sometimes is the only viable answer.
And I really hate to admit this, really do. But operating your own hardware, I'm losing a lot of sleep at the moment. Stuff keeps crashing, I don't know why. It's a pain. And in the vast majority of use cases, if you think about an e-commerce, a standard e-commerce application or a B2B SaaS application, or, well, to be fair, probably 90 to 95% of other commercial use cases, operating your own stack is probably massive overkill, and you might have better security using sovereign landing zones, as you said, and all the cryptographic beauty things that the cloud offers. And you'll probably be much more secure than if you just built it yourself.
So what about we agree on physical custody for really highly regulated or strictly classified workloads under Swiss law?
Yeah, fair enough. And sovereign landing zones and customer managed keys for pretty much all of the use cases.
I agree.
All right. Surprising, we found some middle ground, but on this one, forget it. You have your points with that, with data, not everything's so sensitive, but let's talk about technological sovereignty, right? So technological sovereignty is about who owns the roadmap for your software, I suppose. If you just run on proprietary cloud managed services, right? You don't own the roadmap, you're just renting a black box. you're not technological sovereign if they choose to deprecate an API, or what's currently very in at the moment, double, quadruple their price tag, or even deprecate a service entirely. You're at their mercy, right? You have to either rewrite your entire application or just pay up. You just essentially have to rewrite your entire application. You don't have that problem if you run on fully open source software.
Yes, but you need to understand that we don't write assembly code anymore, we use abstractions. And guess what? Who are the largest contributors to open source? The hyperscalers. Talk about Kubernetes, OpenTelemetry, Prometheus, all backed by public cloud. So you can run managed Kubernetes and still write perfectly standard manifests that are portable. So when you want to avoid cloud APIs, you can also build abstractions using tools like Terraform or Crossplane. And if you really want to bring it to the next level, you can fully abstract using frameworks like Dapper.
Yes, I agree. So they contribute to the core of open source, absolutely. But then they wrap it in layers and layers of proprietary software in order to hook you with convenience. That's not the beauty of open source. If I run my own open source software, I can engage with the community and get information from them. I can upstream bug fixes that I handle, or I can even audit every single line of code that I run. Look at what CERN does, right? CERN in Geneva. They operate massive and complex workloads fully on an open source stack on hardware that they own. If they have a bug, they can fix it themselves. If they don't know how something works, they can look into the code. And if really a larger problem happens, they don't have to call some tier 3 support engineer somewhere halfway across the world in Seattle to help them fix their bugs for them. They can do it themselves.
Yes, but CERN obviously isn't your average Swiss company. And besides, they have a literal army of physics PhDs and system engineers. And Jakob, I mean, do you know how hard it is to hire, to train, and to retain top engineers here in Switzerland? So to find that brilliant admin that runs your Kubernetes at scale securely and also at 3 in the morning. So I say when that guy sees that pager alert, he will leave for a job with better working hours. And on top of that, well, your payroll costs, they will be really high. So while your team is busy coding in exotic frameworks with funny names, my team is moving at the speed of innovation, because I have with a single API call the latest GenAI models at my disposal, or serverless data pipelines, or global edge networks. I mean, let's look at the more realistic case. For example, SBB. They use public cloud capabilities to manage their really big and fluctuating passenger data. They use it for their real-time timetable routing or to power their mobile apps. So they basically trade low-level infrastructure control for scaling and innovation.
If you talk about SBB, let's talk about SBB. They do run their timetables on the public cloud, right? But for safety critical stuff, they of course remain on-prem, because they understand that when safety and autonomy on the line, you can't rely on some external provider deprecating a service or something. And let's talk about talent as well. I'm pretty sure SBB has less of a problem finding talent because they have interesting problems to work on, and they don't just glue together some public cloud services.
Fine. And what happens when you manage those open source stacks when you come across an incident that you can't fix?
Right. I never said that you can't also get support for your open source stack, right? But wait a second. You said before that I could run open source in the public cloud, right? So wouldn't I be able to leverage the public cloud to manage the infrastructure underneath and get the benefits of the public cloud with SLAs and all the operational automation, I suppose, and still leverage the benefits of the open source for the stack on top with community, auditability, and so on and so forth? And since I'm already in the public cloud at that point, I might also leverage the state-of-the-art services and Gen AI and whatnot for experimentation and innovation velocity.
That makes sense. And to be fair to you, I also have to admit that I've used custom hyperscaler services and then ran into issues further down the road. So if you go all in on closed cloud services without an open source alternative, well, that's a risk. So you should probably as a smart middle ground, rely on cloud-hosted open source or at least open standards.
All right, so we essentially run software like Postgres, Kubernetes, Valky, Kafka, whatnot, on the public cloud, and then we can maybe even leverage the annoying stuff like scaling, backups, and patching, and offload that to the public cloud, right?
Yes, that way you profit of the managed services. And you also have an exit plan, because if you decide or you have to move or repatriate, then you can leave for another, for example, a local provider, and you don't have to rewrite your whole core cloud application code.
Yeah, fair enough, fair enough. This feels weird. We're already agreeing on two of those pillars. What's happening?
But I predict that you'll be wrong about the third pillar, the operational sovereignty. Because ask yourself, who's better at running servers? Are you better than hyperscalers to keep them up, scale them? So sharing the responsibility is a feature, not a bug. Because the cloud provider, I let him take care of the heavy lifting to ensure physical security, to do security patching, to replace the hardware. All of this stuff I don't want to do. Instead, my team, instead of focusing on the low-level details, they can do something really meaningful. They can deliver business value.
Focus on business value. You're starting to break one of our ground rules, huh? Focusing on business value, that's the ultimate corporate trap. You're not focusing on anything, you're just outsourcing your core engineering capabilities. You're relying on an army of highly priced external consultants and cloud certified architects, no offense if there's any among you. And your internal team, they don't know how to operate anything. They just click Ubuntu through like some vendor proprietary cloud management console, and you're essentially held hostage by that cloud provider and by their partner network that offers you their consulting services.
Yeah, talking about being held hostage. You think building your own homegrown custom setup makes you independent?
Yes.
If your brilliant sysadmin that built this whole automation system leaves for a competitor, then your operations drop to zero overnight. That's what I call a bus factor risk. So, with the public cloud, you have standardized services. Everything is documented. So there is a massive pool of talent out there with people that know how to do it.
Yeah, it's standardized, but it's standardized to their benefit. I mean, come on, let's be honest. Have you guys ever heard of like how AWS cloud engineers talk and how Azure cloud engineers talk? Sure, they do the exact same stuff, but they speak completely different dialects, right? And even then, they operate black boxes for you. If there's an issue with that, what do? You call that same tier 3 support engineer in Seattle, ring, it's me again, yet again, and you hope that he fixes it for you. He probably knows more about your infrastructure than you do. That's not operational sovereignty. Operational sovereignty is having the internal know-how to understand, control, and maintain your entire software stack.
So the real question is not who owns the real question is actually who owns your GitOps repository that controls your whole infrastructure. Because, you raise a fair point here about the consultant trap. Because if I have to rely on external knowledge to understand my complex cloud setup, then I'm definitely not independent.
Yeah, fair enough. And I do have to admit that a standard IT department of a Swiss company won't probably be able to build the internal know-how to manage your stack from firmware driver all the way to your application logic. And probably if they spend 80% of their time fixing infrastructure automation, you essentially lose your entire development velocity. That's true. So maybe you do have a point that you can rely on the support and the operational automation of cloud service providers. But you still probably should make sure that you understand and you stay in control of how you use those providers.
I agree. So if we come to the middle ground, so we would say it's not about where the hardware sits, but it's about who owns the knowledge of your operational delivery. Mm-hmm. So anyways, you also need to prepare for failure, right? So you need to have a recovery plan in place and you need to test it because, you never know.
True, fair enough. So having a good business continuity management plan and probably fostering the internal know-how to act on that plan is quite critical. And then you can still outsource some of the infrastructure automation to a provider, as long as you remain, I guess, 100% really in control of the logic and how it's operated. So in the end, is as you say, it's who owns the GitOps repository. You need to build on top of those standards, GitOps infrastructure as code, and that way retain the internal control, internal know-how.
So it turns out we agree on a lot more than we thought initially.
Yeah, that's very true. It seems that the whole thing, hey, go full on open source, full on private cloud, or full on public clouds, is sort of a false assumption, right? It seems that digital sovereignty is more of a conscious set of choices and a conscious set of architectural trade-offs, I suppose.
Yeah, and in each area there's a clear spectrum.
Fair enough.
So after discussing through all of these aspects, I think we should turn this into something practical. Because as we introduced in the beginning, digital sovereignty is not a state, it's a decision framework actually. So let's see what we can do to make trade-offs consciously. Let's start with data. So the first question you have to ask is, how sensitive is your data? And do you have any regulatory requirements to operate under? With that, you can do a proper data classification. So you know the risks, what will happen when your data gets exposed, or you get blocked, or somebody accesses your data that you don't trust. And then you can implement the correct measures to mitigate these issues. So for very sensible cases, that might then mean really you want to have as much control as you want, with real physical isolation. You want to have your keys, you want to have full control, and very important, you need the people who still know how to operate it. But for most of the other cases, that will not be needed. You can go with good cryptography, with customer managed keys, with a clear access management. And you have to make sure that you always retain the access to your data, so keep a backup locally somewhere. As far as for the second pillar, the technology, the main question is about speed. How fast do you need to innovate? And sometimes it's perfectly enough to use a proprietary cloud service, for example, for experimentation or for new products. For other services, like core services, you should be more careful. And then it's important to build on open standards, like Kubernetes, like Terraform, like Postgres. So you can also leverage the whole ecosystem for the integration. And regarding lock-ins, it's not about avoiding lock-in at all costs, but it's about doing conscious trade-offs and know about your lock-ins. So the third area is the operations. And here we need to ask, do we still understand our stack that we're operating in? Do we know how our deployment works? Can we debug our issues? Operational sovereignty does not mean that we have to do everything ourselves. But it's fine to externalize some aspects to a cloud provider. So you don't have to care about patching, scaling, and so on. But you must keep the most important knowledge inside, in-house, like about the architecture, about your deployment, and also, very importantly, you have to have your disaster recovery plan ready. So invest in business continuity management and do regular test drills.
And on top of that practical framework, I think there's two very important aspects that you still also need to consider. Is you don't need to do it perfectly from the get-go. The most important part about digital sovereignty is to get started, right? So progress over perfection. You need to get started somewhere before trying to make it perfect across your entire organization. And since we're talking, you need to get started somewhere, the question is, well, where do you start? And there also, focus really on your critical systems, on your critical processes, because not everything in your organization needs to be perfectly digital sovereign. There's different requirements based on how critical those things are, those process or system. And so try to really focus on those before moving on.
That's right. And remember, digital sovereignty isn't a state you can achieve. It's an architectural choice. So use a framework to consciously decide your trade-offs and be aware about your lock-ins.
All right, so to wrap this whole up in one sentence, I guess we could say don't let marketing departments define your digital sovereignty, but also don't let paranoia completely stall your innovation. Thank you very much.